Another LeetCode medium problem. House robber number 198. You are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected, and it will automatically contact the police if two adjacent houses were broken into on the same night. Given an integer array nums representing the amount of money of each house, return the maximum amount of money you can rob tonight without alerting the police. So another maximum minimum problem with an array of values, which means dynamic programming once again, but it's best if we can observe the optimal substructure of this specific problem. So let's come up with a function. Let's call it rob from n, and let's say so at each house we have a choice to either rob it or skip to this house 2 across, right? So we can either rob this one or skip 2 across. We rob it and then move 2 across. We either rob it and move 2 across and then rob these, or we rob these ones and skip this house completely. So you can see that we actually have a simple max-min problem. We're looking to rob the maximum that we can. So this is going to be the maximum between we can either choose to rob this house, so this would be nums n, so the nth house, plus the rob from n plus 2 versus rob from n plus 1. As an explanation, n is the position we're at, so obviously we're looking for rob from 0, where we're starting at the beginning of the array and we're robbing all of these houses across from the street. Rob from 1 would be if we were to rob from this point onwards. Rob from 2 would be this point onwards, and so on and so forth. So at each house, at each point, we have the choice to either rob it, take the money, and then rob the houses 2 across from us and find out what the maximum is from this point onwards, or we can find out what the maximum is from this point onwards and ignore the house that we were robbing. So that's the recursive relation. Some edge cases and base cases. So our edge case would be if nums empty, return 0, because obviously if the street's empty we can't rob anything. Base case 1. Now it makes sense that we're going to actually have to go through this decrementally, because at the end of the house we'll have our base case. So obviously at the end of the house we can only rob, at the very end we can rob nothing. So if rob from n, where n is nums.length. So if we're right at the end, rob from n is going to be 0 because we can't rob anything. So base case 2 would be, so if we're at the nums minus 1, we're at the very last house. We can't rob anything else except for this house. So rob from n minus 1 would be equal to nums n minus 1, right? Because then we can only rob this house. There's no extra houses we can rob. So having established the base cases and the edge case and the recursive relation, we can actually immediately start coding the solution, which is going to be simple in Java. So because this is a maximum problem, we can initialize our arrays without having to do any padding, because it's already 0 instantiated and we're looking for a maximum. So let's just declare a variable n, which is equal to nums length. This makes our life pretty easy because this just track it without having to type nums length every time. Let's create an integer array called dp, or indeed rob from, to make it similar to how I've written up there, which is equal to a new integer array, and we'll assign the length n plus 1 to it, so that we can get the case at the very end of the street. And then it's pretty simple. All we have to do is just establish the base case constraints. So rob from n is going to equal to 0. Rob from n minus 1 is going to be equal to nums n minus 1, which is fairly straightforward. And then all we're going to be doing is we're going to be generating this iteratively and tabulating our results for instant lookup. So we're going to be going for int I is equal to n minus 2. We're going to be going I greater than or equal to 0, I minus minus. So why am I decrementing? As I've said, because we're starting from our base cases are at the end of the house, we have to generate all the results from going back here and then back here to ultimately generate our result for the start of the street, so rob from 0. So we have to start from n minus 2 because we've already established the cases at n minus 1 and n. So then rob from I is going to equal the maximum of rob from I plus 1 versus nums I plus rob from I plus 2. This is to generate our recursive case and generate all the values that we can use for instant lookup because it's in an array. And then all we simply have to do is we return rob from 0. I'll run this. Great, instant. It's not that many lines of code either, only about 12 lines of code, so pretty nice. And to do a quick complexity analysis, the time complexity of the problem is going to be equal to O of n, in this case where n is the size of the array because we're generating all the possible positions from the very start or the very end of the array rather to the very start, so 0, so it's going to be scale linearly with n because we're only doing one loop. Space complexity will also be equal to O of n because we're allocating an array of size n.